tell whether each sequence is an arithmetic sequence or not, and why. How will we know if a sequence is an arithmetic sequence? If it is possible to find a common difference, then it is an arithmetic sequence. Or if it is possible to find a constant number that if you add to each term, you're going to get the next term, then it is an arithmetic sequence. Now, from 1 to 5, that is addition of 4. So 1 plus 4 is 5. Then let's try 5 plus 4, 9. Okay, it's good so far. Then 9 plus 4 is 13. 13 plus 4 is 17. So, the rule of adding by 4 is applicable. There is a common difference. Therefore, yes, it is an arithmetic sequence. For number 2, okay, let's say we have 3 plus 3. That will give us 6. Okay, 3 plus 3 is 6. And then 6 plus 3 is 9. But the number here is 12. Therefore, since the rule of adding by the same number does not apply, then there is no common difference. And therefore, this is not an arithmetic sequence. For number 3, okay, so 18 to 13, that is subtracting 5. So 18 minus 5 is 13. Now, even if we say that we must be able to find a number that must be added to get the next number, subtracting is also applicable because subtracting is the same as adding the negative inverse. Okay? So, if we can find a constant number that can be subtracted from each term to get the next term, then it is an arithmetic sequence too. So let's have 18 minus 5, that is 13. 13 minus 5 is 8, correct so far. And then 8 minus 5 is 3, correct also. And 3 minus 5 is negative 2. Therefore, this is an arithmetic sequence. Number 4, 5, 16, 27, 38, 49. What do we add to 5 to get 16? That is 11. 5 plus 11 is 16. Plus 11, 27. Plus 11, 38. Plus 11, 49. So, there is a common difference, and so it is an arithmetic sequence. Oh, by the way, before we proceed to number 5, if you notice here, there are ellipses at the end of the sequence. This just implies that the sequence is infinite. Okay, infinite, while this one is finite. Finite, infinite, infinite, finite, infinite. Now, let's go to number 5. What do we add to 2 to get 4? We add 2. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2 is 8. But the number here is 9. Okay. Let's try. 9 plus 3 is 12. 12 plus 3 is 15. Okay. Even though the first three have a common difference and the next terms have a common difference, still, we cannot say that there is a common difference that is applicable to the whole sequence. Therefore, this is not an arithmetic sequence. How about number 6, 7, and 8? Will you try to answer this? Write your answer into comment sections, please. Thank you. Good luck.